Good afternoon, everyone, and welcome to part one of the Pedestrian and Bicycle Transportation course. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation in this training. Please note that today's session is the first of a four-part webinar series with part two tomorrow and parts 3 and 4 next week. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. And during the course presentation, please use the questions box to send in any questions you might have, and I'll be dispatching those periodically to the instructor for comment. Please note also that the handout section of your GoToWebinar panel includes several PDF resources that we'll be referring to during this course. With that, we'll go ahead and introduce our instructor, Ron Eck, with the West Virginia LTAP Center. Ron, welcome.
Thank you, Mike. Welcome, everyone. This is, as Mike said, the session on bikes and pedestrians. I call it Meeting the Needs of All Users, and I'm pleased to be here. You have my email address is there on my title slide. Feel free to contact me after the session if questions or concerns arise. But I think before we get into the technical content, I'll turn it back to Mike to do a couple polling questions to give me an idea of who's here in attendance this afternoon.
Sounds good. Thanks, Ron. And we have launched our first poll question, and we will give everybody some time to respond. From where are you joining us today? And we see the responses arriving already. Okay, about 80% have voted so far. That's good. All right, let's see our responses. So Ron, we had 63% said they are joining us from home, 37% from the workplace.
Okay, interesting. Thanks.
Yep. And then do you want, we can go ahead and do the second poll question?
Yes, please.
Okay. So here we go. What is your main role in public works or multimodal transportation? And you can check all that apply for this question. Okay, votes are arriving. Okay, lots of good responses. Okay. So Ron, we had 51% said planning, 65% design, 19% construction, 17% maintenance, 29% administration or management. So of course, with multiple choices that people can choose, you know, they add up to more than 100, but a lot of folks in design, a lot of folks in planning.
Yeah, good. It looks like we have a good diverse group, so hopefully we get a lot of good, interesting questions. Just to reiterate what Mike said, please feel free to use the chat box if you have a question or a comment or an experience to share. Yeah, the questions box, yes. If you have a question or comment or even experiences to share. Well, let's get started. My main objective today and over the 3 days that follow is to give you some information on designing, building, operating, and maintaining safe, comfortable, accessible communities so that walking can be a viable form of transportation for everybody, including seniors, children, people with visual and mobility disabilities, and also so that bicycling is a viable transportation choice for people of all ages and abilities. Just before we get started, kind of overview our agenda of what we'll be talking about. This is what we'll talk about today. I've highlighted it in red. We'll do some introduction and background, talk about the importance of accommodating bikes and peds, look at connections, connectivity. Then I feel in order to be able to design and plan for pedestrians and bicyclists, we need to know something about their characteristics. And so we'll spend a little bit of time looking at the characteristics of pedestrians and bicyclists. Then we'll look at design flexibility, some design controls, and some design elements. And then tomorrow we'll continue the design theme. We'll look at cross-section elements. As part of that, we'll also look at rumble strips because they're significant when it comes to bicycling especially. Then we'll look at what I call sidewalks and associated environments. Then we'll look at pedestrian crossings, namely crosswalks. Then we'll look at roundabouts, a little bit about overpasses and underpasses. Then next week, day 3, we'll look at pedestrians and bicycles at interchanges, look a little bit at bus stops, talk about maintaining roads and streets for all users. And we'll also look a bit at bicycles and pedestrians and work zones. And then our final day next week, day 4, we'll focus mostly on bikes. We'll look at bicycle facility types and some of the considerations associated with the various types of bike facilities. We'll look at bikes and on-street parking. Also look at shared use paths, and then we'll wrap up with hopefully tie that shared use path together with some of the other things we've talked about and look at a rails with trails example and talk about that a little bit and some of the considerations and issues and how those might be and were addressed. So that's an overview of what we'll be talking about. Start out with a little bit of history of walking and bicycling in the United States. Of course, before about 1900 or so, pretty much everybody was a pedestrian. Bikes became popular in probably the 1890s. But of course, the roads were not in very good condition. Most of them were not hard surfaced. So in the early 1900s, there was what was called the Good Roads movement, which was pushing to get good hard surfaced roads or get the farmers out of the mud. You've probably heard that expression. And as you may be aware, one of the leading sort of lobbyists for that Good Roads movement was actually the bicycling community. They were pushing for good hard surface roads. So it was not only the motorized, the folks with motorized vehicles, but the bicyclists were also lobbying for good roads. And then we start to see this sort of evolution of street use, like you see the image in the bottom right there, kind of multimodal at the time. You see pedestrians on the sidewalk, you see a horse-drawn wagon or cart there, but you also see a streetcar in the center of the image or in the middle of the street. And back then, development was strongly influenced by the transportation system. People probably lived within kind of the range of the streetcar line. And I remember my grandparents, when I was growing up in the 60s, they were in eastern Pennsylvania in a small city which had streetcar system. And my grandparents actually never had an automobile. I mean, they were able-bodied and could have afforded it, but they lived in a city that had a streetcar line and later a bus system, and they could use that to really get anywhere they wanted to. And so that's sort of what you see there in that image in the bottom right. Then in the mid-50s, we had one of the big, I guess, legislative actions that affected not only those of us in transportation, but literally affected kind of the culture and sociology of the United States, I think it's fair to say, was the Interstate and Defense Highway Act, which was intended to connect urban areas of greater than 50,000 population with limited access roadways. And we could probably spend a good deal of time just talking about some of the consequences of that. We're not going to do that. But it did lead to a sort of expansion outside of urban areas, but also, of course, did probably adversely affect neighborhoods within these cities and built up areas, either by the removal of the neighborhood for destruction and removal of the neighborhood for the highway construction, or even if the neighborhoods were not directly impacted by construction, the fact that you had these large kind of multi-lane corridors going through the city did, and I guess to this day still does, sort of divide neighborhoods and parts of the city, because these act as effectively as barriers between different parts of the city. But then one of the other things that happened was, of course, now with this system of limited access highways, folks could live outside of the city on a plot of land and have some green space and a swimming pool and all those amenities, and then commute to and from work in the city. And so as you see in the bottom right there, that led to this phenomenon of suburbanization, where you had these cul-de-sac streets and residential areas. If you look at it, they're not very well connected, really not designed for through traffic. But then also you had other land uses like parks and recreation, or schools and shopping. They tended to be segregated in their own parts of the area. And the result was that someone, unlike, say, my grandparents, who could walk and take the streetcar pretty much everywhere they needed to go, in suburbia, one has to have an automobile to be able to get around to conduct their activities of daily living, whether it's school, shopping, work, or even recreation. And so that obviously has profoundly affected transportation. And here's just a simple example of what I call the influence of automobile on design. If you look at the pointer here, if you look at the image on the left, I mean, this is not the street my grandparents lived on, but it looks very similar. There were row houses, pretty dense residential development. This looks like it may be retail, restaurant type things on the first floor, and then probably residential on the second floor. But notice the sidewalk is fairly wide. There's no off-street parking. All the parking is on-street metered parking. But and that's probably was developed even before the automobile came into wide use. But then if you look at a more modern development, I think this is in Florida, one thing that strikes me looking at this image on the right is, even though this house here in the right center does have a little porch here, the thing that strikes me about these homes is, notice the front tends to be dominated by the garage door and the wide driveways. So you can see the influence that the automobile has had even on sort of residential structure or residential home design. And it's entirely different environment from the one on the right. Notice there are sidewalks here, but it's not the same sort of feel, if you will, that you would have walking on a sidewalk like here on the left-hand side, where you're very close to the porches and front doors and things of the homes or businesses. And then this I took one Sunday morning in Seattle a few years ago, and I just thought this was sort of neat. Notice you can see many modes here. You see vehicular traffic, of course, motor vehicle traffic. You can see some bikes there at the bike rack. Pedestrians walking, others are sitting and chatting and just enjoying the good weather at the cafe there or coffee shop. And I mean, there's maybe some issues here. The sidewalk might be wider. Maybe the bikes shouldn't infringe on the pedestrian travel space there. But all in all, I just thought this was a nice kind of environment where you can see all users kind of reflected. And the fact that we see so many folks in this image, to me, means there must be something that attracts people there, and to make it a popular location. So kind of what lessons can we learn from that? And we'll talk about some of those things. But the challenge is, a lot of our built environment looks like you see on the right-hand side here in suburbia, wide arterials to accommodate vehicles, and a lot of, for example, driveways to various land uses of all sorts, but not really a very pedestrian or bicycle friendly environment. So our challenge is, how can we kind of retrofit the environment to encourage and make walking and biking more friendly, and as well as manage the conflicts between modes that inevitably occur. So for example, we see here, it looks like a signalized intersection in the photo here. you can't really see the details of that, but that would be an example of a conflict of pedestrians crossing versus moving vehicular traffic. I took this in eastern Pennsylvania a few years ago. I call it a typical residential street. The thing that strikes me is how wide this street is. You can see some parked vehicles on street parking in the background, but if you look closely, the homes have driveways and garages, so they probably, for the most part, don't really need on-street parking. But the street is wide, straight. Looking into the picture, it's coming downhill toward us. So you probably would not be surprised to learn that the main concern residents of this neighborhood have is high-speed traffic on this roadway or on their street. And maybe some of you have seen this bar chart before. This shows the pedestrians' chances of being fatally injured if struck by a motor vehicle. And notice at about 20 miles per hour, there's about a 15% chance of being fatally injured. So what's that, about 1 in 6, 1 in 7 chance. At 30 miles per hour, that goes up to almost half, 45% likelihood of being fatally injured. And then at 40 miles per hour, it's almost likely to be a fatality, 85% chance of death. So to make pedestrian-friendly facilities, we want to be looking down here in 20, 25 mile per hour speed range or so. And even though that street you saw on the previous slide was posted for 25, the prevailing speed of traffic is certainly much higher than that, just given the design of the street. So a typical street, may have high travel speeds, a lot of driveways. If it's a commercial area, the parking lots usually front the street rather than that scene I showed you where the buildings are right up against the sidewalk. If there are sidewalks, they tend to be narrow. Tends to be a lack of connections. I'll give you some examples of this here in a few minutes. No amenities, and by amenities for pedestrians, I'm talking about things like maybe shade, benches to sit down, a wayfinding system of signs and so forth that's designed for pedestrians, not really for motor vehicles. And then just because people over the decades have sort of focused on the automobile rather than pedestrians, we often find unintentional barriers to pedestrians. And here's an example. This is in this community or in this neighborhood, this is considered or classified as a residential street. I took this in Las Vegas a few years ago. This is actually North Las Vegas. I was there for an Institute of Transportation Engineers meeting and signed up for a traffic calming field trip. So they took us up here to meet with some of the residents and some of the engineers and planners. And apologize for the quality of the image there, the reflection, but I took this from a bus that we were on the bus to get there. But it struck me, think about that. To me, this is maybe fine for motorists, although it's posted at 25. And certainly the residents had stories of prevailing speed being around 50 miles per hour, which is probably not surprising because to me, with this is a walled and gated community here, which is fine, but would you agree these walls here almost create the effect of a racetrack, like a NASCAR track here on the roadway? Notice on the sidewalk, there's no amenities. I should tell you, I think the day we were there, it was in August, I think the outside temperature was like 107 degrees Fahrenheit or something like that. So it certainly would not be very pleasant to walk on this sidewalk in the daytime, in August in Las Vegas. And so this is another example of what I'm talking about. To me, the street is really over designed for a residential street, and just some of the characteristics tend to encourage higher speed, but then it really has a lack of kind of pedestrian amenities, things to make it an attractive environment for pedestrians to walk. Or here's a simple example of just an unintended barrier to pedestrians, just lack of maintenance of some bushes or vegetation that's essentially overgrown the sidewalk, creating a barrier. But I would also contend that may create some security issues there, that you have these sort of blind spots and that sort of thing, hidden areas that certainly don't give one kind of a sense of, security and safety if they'd want to walk on that sidewalk. So why should we accommodate pedestrians and bicyclists? Just a few facts. 1 in 10 US households don't own an automobile, maybe due, for example, to income levels, that sort of thing. About a third of the population does not drive a vehicle. And this could be young people, younger than, say, age 16 or 17 or whenever you can get a driver's license. It may be individuals on sort of the other end of the age spectrum, older folks who maybe voluntarily or otherwise no longer drive just because of their physical condition. There may also be a group of, and there are groups of people that suffer from various disabilities or impairments, notably vision or blind pedestrians, low vision or blind individuals who cannot get a driver's license. So a significant part, 1/3 of the population, it doesn't drive. So we need to have, I think, some other options beyond driving for short trips for the individuals I've just talked about here. So if we can have multimodal networks that serve vehicles, bikes, and pedestrians, this will give access to jobs, education, healthcare, and other services, both in urban and rural areas throughout the country. And likewise, if we have a interconnected ped and bike infrastructure, makes walking and biking a viable choice for everybody, which has benefits of provides physical activity. So hopefully we'll have a healthier community. Sorry about that. More equity in terms of folks being able to travel to various destinations, regardless of whether they have an automobile or not, and just a general enhancement of the quality of life in our communities. The decision to walk or bike, though, is interesting. It's not always as straightforward as one might think. There's really a hierarchy of factors that influence people's decision to walk or bike. At the first level, there's what I'd call the initial considerations. And one of the big ones here, at least in the past, has been people don't just think about, they don't even think about it. They just jump in their car and travel somewhere. But maybe they should give consideration to walking or biking, or maybe, maybe as I guess today in some parts of the country, bitter cold or icy pavement conditions, sidewalk conditions. So it's just, I'm not going to go out under these conditions. But if you can overcome those initial considerations, that may not be enough to get people walking or biking. Then there's trip barriers that have to be overcome. I mentioned one trip barrier earlier might be just sort of personal security concerns about walking through a particular area. Then there may be kind of personal safety concerns because the sidewalk may be right up against traffic. There may be no buffer strip between the sidewalk and traffic. The sidewalk may be heaved up or potholed or in bad condition. So people just have kind of safety concerns about making the trip. But even if you can overcome the initial considerations and the trip barriers, there may be destination barriers, particularly for bicycling. For example, a bicyclist needs and wants a safe and secure place to park their bike, say during the school day or the work day or whatever it might be. So lack of adequate or safe and secure bike parking would be a destination barrier. Or if someone's walking or especially biking, for example, say in the summertime to their workplace, when they get to their workplace, they'd like to have a place to shower and change before they head to their specific office or whatever it might be. So lack of, say, showering facilities, change facilities might be another destination barrier for bicyclists. Been talking about connectivity. The automobile has obviously influenced that as well. Notice on the left here, we have one of these cul-de-sac residential communities. I think if you live on this cul-de-sac here in the center, you don't have to worry about through traffic. That's certainly one of the benefits. But on the other hand, notice that the connections are not very good. Imagine I'm a pedestrian, or imagine I'm a young person that, say, lives in one of these homes here. Maybe I'm, I don't know, 10, 11, 12, 13 years old, so I don't drive yet. And maybe my best friend lives over here. As the crow flies, that's not a very long distance, easily walkable. But if you notice closely, it looks like almost every one of these properties has a significant fence or landscaping around it, which is to be expected. So, but it's not like one can just take that straight line distance. One would have to walk out of the cul-de-sac to this street and then walk around to this particular home. At least it looks like here there are sidewalks, which is not always the case. But at that age, my parents may not even want me to do that on foot. They may insist on driving me from home to my friend's home. So not very good connectivity in terms of pedestrians and bicyclists. And if we look at the image on the right here, this commercial establishment, notice in the right here along the frontage here, there is no sidewalk. It looked like a sidewalk down here and a sidewalk here, but there's a gap here with no sidewalk, which presents an issue for all pedestrians, but maybe especially those headed for this front door here. And notice that walking through or across the parking lot will certainly be an unfriendly experience for pedestrians with all the conflicts and interactions with vehicles. One thing I would note, it maybe is unusual, notice there it does appear to be a connection here to toward the front of the big box store, which we don't always see. Here's an example from my community. I'm here today in Morgantown, West Virginia, north central West Virginia. And I don't mean to pick on this firm, although I think at one point their advertising tagline was your neighborhood bar and grill. And this is actually in my neighborhood in Morgantown. It's not far from where I'm speaking to you from right now. But notice, and it's the front door is not that far from the roadway, but notice, I would think there maybe should be a connection, sidewalk type connection from the sidewalk here along the arterial to the front door. And I'd further note too, you can't see it, but just outside the image here on the left is actually a hotel, a relatively large hotel. And there is now finally, but when the hotel opened, believe it or not, there was no connection. You had to walk through the grass and the mud to get from the hotel to the front door of this eating establishment, which to me, that seems to be a natural connection that was missing. But if I wanted to get to the front door of this facility, really what I need to do, as you can see down here, I need to really walk past the parking lot and then onto a fairly busy driveway that has no sidewalks and serves all other land uses, and then walk back across the parking lot to the front door. Whereas maybe had a little bit thought been given to putting in a pedestrian connection from the beginning here between the sidewalk and the front door of the building, that might have, I think that would have been a much improved situation, would have provided a logical connection. But we've talked about some disconnected street networks, cul-de-sac type developments, even major arterial streets, because of the number of lanes and the traffic speeds, they can also create disconnected pedestrian networks, or at least they're challenging for pedestrians and for bicyclists to cross. So if we can think about kind of small blocks to reduce the pedestrian need to walk through parking lots or undeveloped areas, think about connecting those cul-de-sac streets through some system of maybe shared use paths, but also recognize that we may have other sorts of barriers to connectivity Sorry about it, must be on automatic here. Such as an interstate highway, I mentioned that earlier, or railroad tracks that can create barriers to people on foot because there's such infrequent crossings. And here's an example. This is from the Portland, Oregon area. This is a relatively, relatively new cul-de-sac, but notice from the beginning, they put in this sidewalk or path intended for both bikes and pedestrians to provide a connection to either the adjoining cul-de-sac or to a park or to a school or what have you. But if you recall from the previous slide, once the homes are built and people have their landscaping and fences, the ability to do this sort of thing is probably almost nil. So it's important to do that from the beginning, from the planning stage. But this is a good example of being attentive to a needed connection. So network connectivity should provide connection facilities for pedestrians and bikes, can promote walking and biking, as well as reduce conflicts with motor vehicle modes. And so think about forming a network for people of all ages and abilities. Here are just a few examples. This would be creating some networks near schools, for example. Notice we have a high school here on the left side, have a couple population centers here, and you can see part of a road network. You can see there's a transit system in this community or communities. And so notice near the school, there's a side path adjacent to the roadway so the students can bike, out of traffic, if you will. Between these built up areas, we have an enhanced shoulder, and hopefully there's connections to the transit stops as well. So we connect not only to the road facilities, but to transit. So I think we've talked about this. Think about narrowing travel lanes to reduce speeds. Using crossing islands, median refuge areas to reduce crossing distance for pedestrians. Think about enhanced treatments at uncontrolled crossings like a pedestrian hybrid beacon or rectangular rapid flashing beacon, something like that. In a more rural area, here we have you can see, we're calling it the rural core, maybe an unincorporated sort of community, maybe one sort of main roadway through town, maybe use a bicycle boulevard concept, which we'll talk about on the fourth day, to make that a little more bicycle friendly, or use enhanced shoulders through the community and out into the rural area to encourage bicycling. Where we can think about separated bike lanes on a higher volume, higher speed roadways. Think about standard bike lanes to define space for bikes. On rural roadways, think about providing paved shoulders. We'll talk a little bit about that. And then also think about enhanced treatments at uncontrolled crossings of higher volume, higher speed roadways. And here's thinking about networks where you have shared use paths. Notice there's a shared use path here highlighted in red. Notice all the connections that have been made to cul-de-sacs, or notice here even between cul-de-sacs, or like this, notice here we have a grocery store, food store. Notice there's a connection to the state road here, and then they highlight a crossing improvement to make that a friendlier crossing for pedestrians. And so we need to think about those kind of connections wherever we can, which will increase the use of the shared use path, probably for both transportation and recreational uses. And I think we've talked about these. Again, notice wayfinding, that's important. So a signing system, so the users of the shared use path have the directional and wayfinding information that they need. Here's an example. This is not too far from that Pennsylvania residential street I showed you. This is a popular shared use path in the area. You can see it here. One thing I noticed somebody's even plowed it and treated it for snow and ice in the wintertime. Up here is a relatively new cul-de-sac type subdivision, and we can discuss and debate the accessibility and the design of this connection. But I guess what I wanted to highlight most is I'm at least glad that somebody was thinking about making that connection here from the end of the street to the shared use path. Whereas this one is a short distance away from the scene I just showed you, the same trail. It looks like an older subdivision and look more friendly topography. Looks like a sidewalk here, but notice there's no formal connection between the sidewalk or the street and the trail. To me, with just a little bit of work and not a whole lot of dollar expenditure, I think it would be possible to make that connection, which would, I think, just be better overall, both for pedestrians and bicyclists. So those are the sorts of things we need to think about. And not only from a construction standpoint, but given the situation you see here in the scene, if you do have a connection between the trail and the sidewalk, make sure that that is cleared of snow and so forth. Let's see, that back here, that could be an issue. Notice it's a detail, probably takes some manual labor, but there should be some sort of clearing or treatment or removal of the snow and ice at the base of the sidewalk here. So we looked at connections. We've talked about pedestrians and bicyclists. I'd like to spend a little bit of time looking at pedestrian and bicyclist characteristics. We'll start with pedestrians. Certainly they're the most vulnerable road users. They're at the greatest risk of injury or death if they're struck by another road user. We might think about, I apologize for that. Somehow it got on automatic here. But pedestrians, the basic characteristic is, of course, they're walking, or ambulation, as it's called. And if you think how we walk, we sort of push off the balls of a foot and then go through the kind of the walking cycle and then come down usually on our heels and then rotate the ankle and start the whole cycle over again. Normally it goes without a hitch, but sometimes if there's some sort of obstacle in the path, pedestrians could trip, or if there's some sort of change in traction of the surface, when that heel comes down, the heel may slide and there could be a slip condition. And both of those represent pedestrian safety issues. Another thing to consider about pedestrians, especially this time of year, at least in much of the country where a lot of us have snow and ice covering our areas now, including the built environment, pedestrians typically don't walk looking down at their feet. Their line of sight is 15 degrees below horizontal. Why is that significant? Well, if you look at this image here, notice in the upper left, notice this heaved up sidewalk slab, probably due to a tree root associated with this tree. At least this one and this one here have been painted yellow to highlight them. That's a good thing. But imagine, let's say this wasn't painted yellow to highlight it, and let's say I was walking on the left side of the sidewalk. If my line of sight is 15 degrees below horizontal, that means I'm looking probably about 15 feet, 20 feet ahead of me. And so when I see that from 15 feet away, if it's not painted like that, to me it looks like it's just a regular joint in the sidewalk. And so when I get to this point, I'm looking 15 or 20 feet down the sidewalk, and I'm not paying attention to this thing that could catch my toe, and then I trip and fall, maybe fracture a collarbone, and then file a lawsuit against the municipality. That's not an uncommon occurrence, as probably many of you know. So we need to keep that in mind, kind of the human eyesight and ambulation characteristics in assessing some of our walking facilities. Or how about this one here in the lower right? This is in West Virginia. Originally, these wheel stops for the parking lot were lined up along the edge of the sidewalk, but since it's in snow country, it's amazing how these things move around or are moved around by snow plows and snow fighting equipment. And so you can see most of them are in the parking lot, but this one and some of these others are partially infringing into the sidewalk area. And this one is a real concern to me because notice while they were originally painted yellow and visible, the end of this one is not. And so it may not be observed by a pedestrian, 15, 20 feet away that this is an obstacle in the walking path. So I call these non-motor vehicle related pedestrian incidents, and they are significant, especially for local governments. Think about some data here like I've presented. Falls are the leading cause of non-fatal injuries for pedestrians. They actually exceed those related to motor vehicles. Now, admittedly, not all of them are in the public right-of-way. Some of them occur on private property, but falls are a significant issue for pedestrians. And actually, pedestrians falls account for about 1 out of every 5 visits to hospital emergency rooms, or at least that's pre-pandemic, that data was correct. Here are the basic conditions of the walking surface that can cause falls. We've talked about some of these. An unexpected change in traction of the walking surface, could be water or some sort of motor oil or something on the sidewalk. Could be, this time of year, it could be ice or snow. Could be an unexpected change in level of a walking surface, like the heaved up sidewalk slabs I showed you. It could be an unexpected impediment, some sort of feature, and I'll show you an example here shortly, in the walking surface, or it could be a variation in stair geometry. Here's some changes in traction. Notice you have water, and here on the left, carrying actually some mud across the pavement. So now we have a slippery condition here across this sidewalk. On the right scene, this is in snow country. During the winter, the road agency put down, probably on the road, and it ended up on the sidewalk, but abrasive materials for anti-skid. And now you have this loose material on the sidewalk and actually on a gradient, and that can be very slippery and lead to fall accidents because of a change in traction. Here's an example of an unexpected impediment, water meter related feature that many municipalities use, but can also be an impediment to pedestrians. With traction related falls, or the slips that I mentioned, usually the pedestrian falls backwards. These are, of the 2 types of falls, trips or slips, these are the most serious. Usually the pedestrian gets a fractured hip, or if they, just like sort of a football player, when they hit the turf, that your head can come back and strike the surface, concrete or asphalt surface. So there's head injuries, spinal cord injuries. So typically slip-related falls have more serious injuries. In the trip-related, the pedestrian usually falls forward because their 1 foot's motion has been impeded while the upper torso still moves forward. So they fall forward. And the typical human reaction is to throw out your arms or your hands in front of you to catch yourself. And so you'll notice the typical injuries are related to that, like fractured collarbone, fractured wrist, bruised knees, abrasions on the hands and the face, and that sort of thing. One of the big changes in level or elevation, if you will, is what I call the single step, like you see here, which we see a lot of in the built environment. They're recognized as not being very safe because they're unexpected, but the building codes and that sort of thing don't really prohibit them. So the situation here would be for a pedestrian walking from the right to the left is they wouldn't expect that single change in elevation, which might be anywhere from maybe 4 to 8 inches or more. And so they make an air step, they step off into the air, and that may cause ankle injuries or loss of balance and a fall. And as I say, there's a lot of these in our built environment. Here's just one example from a small city. Notice from below, you might wonder how someone could trip and fall because it's pretty obvious. And that's true. And most people don't fall going up. They fall going down because that step is not visible. And notice here on the right from above, you can kind of see the nosing here, but it almost looks like it's another joint in the sidewalk. And pedestrians, unless they're paying close attention, not see that and may end up tripping over that single step. Another characteristic of pedestrians, and this is to me a human characteristic that we all have, is that unless we're physically prevented from doing so by some sort of barrier, pedestrians will always take the shortest and least energy path between 2 points. I used to teach at West Virginia University. I taught the transportation classes, and I always used to, in my traffic and pedestrian classes, I'd talk about this situation here on the left. This is a college campus, and I said if I was ever in charge of facilities at a college campus, at a new college campus or new buildings, I think I'd wait to put the sidewalks in until the students had worn paths in the grass, and then I'd put the sidewalks there. And I think this is a good example of that. Sorry about that. I'll correct that for tomorrow. But notice here, the architect or designer put in a nice curvilinear sidewalk system here, but apparently the students were just walking across the grass following the straight lines, short distance path. And so eventually the university had to come in and put in this railing system to try to control the student movement. Here's same campus over here. This is the campus here in the foreground where my cursor is. The residence halls are over here, and in between is a 5-lane, pretty busy arterial. And so the university put in a overcrossing structure, but you probably are not surprised to learn the students continue to cross at grade. So I think you maybe can see it in the background. What they had to do was actually put up a chain link fence on the back side of the sidewalk there along the arterial to prevent students from continuing to cross at grade. And sadly, I see that a lot. A lot of money spent on nice, attractive overcrossing or undercrossing structures, but unless we put some sort of barriers in at grade level, pedestrians are still going to take that path rather than use the grade separated structures. And then how about this one? This is interesting. This, you can see, it's not a very pedestrian friendly environment. It's along an arterial. And so this particular agency, road agency, put the pedestrians prohibited sign, which is in the manual and uniform traffic control devices. But I have a couple of issues with this in this application. Number one, this sign alone would be a violation of the Americans with Disabilities Act, because not every pedestrian can see that. A blind or low vision pedestrian can't see that sign, and so they don't know that the pedestrians are prohibited. So if we want to kind of prohibit pedestrians, we really should put up some sort of railing or barrier or something to prevent the visually impaired, or else have a detectable end to the sidewalk system so that they know the sidewalk system doesn't continue. But then what you can't see here maybe, and another reason I'm sort of criticizing this, is beyond this freeway, out of view here, is on the other side is a large regional mall. And in the foreground, we'd come out of the slide to the foreground, is an area where there is some subsidized housing, a number of folks who don't have automobiles and who work in the service portion of the mall in the background. And so their really only option, there's no transit in this community, so their only option is to walk to the mall from their home. And this is the path they need to take. That's why you can see a well-worn goat path here, is because folks are walking to and from work. So to me, to just sort of, prohibit pedestrians may address a safety problem if in fact pedestrians comply with this, But really, the pedestrians that you see here are just trying to get to and from work, so they're probably not going to be deterred by that sign. So maybe some other approach to the underlying safety problem, to me, seems to be more appropriate there. Another characteristic of pedestrians, and this one really concerns me, to me it's almost like a public health issue, is that pedestrians overestimate drivers' ability to see them, especially at night. The visibility of a pedestrian in traffic depends, of course, on what they're wearing, the vehicle, the headlamps of the vehicle, and the driver and the driver's visual capabilities. So let's look at motor vehicle headlamps. You've probably seen there's a lot of variation in headlamps. If you just look when you're out driving or walking on the roadway at night, various colors and intensities and arrangements of the lights. So each driver almost is seeing something different when it comes to the roadway that's illuminated ahead. But one thing I wanted to mention is that the original pattern of headlamps in the United States up until maybe 20, 25 years ago was what's called the sealed beam pattern. And let me get all this up here. And this would be, imagine you shined your headlights on a wall or on your garage door or something like that. And this vertical line is sort of the vertical axis and the red lines are the horizontal axis. Notice that in the United States, our headlamps have what I'd call a lower right bias. Notice the most intense light is in the lower right quadrant. And there's a couple reasons for that, at least. One is by aiming the brightest light here, the light is not shining into the eyes of oncoming motorists, so you can make your headlamps more intense and not blind oncoming drivers. But also, drivers oftentimes use the white edge line for guidance on the roadway. And so this area would be where the white edge line is. And so having that lower right bias illuminates that edge line. But if you look closely, you can see, even though there's not much light up here, there's still a little bit of light up above this red center line. But then about, I don't know, 20, 25 years ago, and really they did it on their own with really no discussion or interaction with the highway engineering community, the automakers went to what they call the cutoff pattern. And I think here you can maybe see why they call it a cutoff pattern. Notice the lights still have a lower right bias, but notice that above this line, there's really no light. That looks almost like pitch black there. And most new automobiles have this cutoff pattern. Think about it from a roadway standpoint. Where are the signs that we use out on the roadway? Well, they're probably located, say, up about this height. And in fact, this was one of the impetuses for the Federal Highway Administration in 2009, adding a section to the manual and uniform traffic control devices to include minimum required retroreflectivity requirements, is because with these cutoff headlamps, signs were not as visible as they would be under sealed beam headlamps. But think about it too, this also affects pedestrian safety. If a pedestrian, they're wearing a black, say a black hoodie or something, or a black outer garment in the wintertime, they may not be visible at all to a driver until it's too late for the driver to stop. And especially this left quadrant here, really no light to speak of is available to see a pedestrian crossing from the driver's left to right. And I think here in my community, the last few nighttime fatal pedestrian crashes we've had, that was the characteristic. The driver or the pedestrian was coming from the driver's left. And those of you that are involved in traffic safety or pedestrians, you might look at your crash data. I'd be willing to bet most of your nighttime pedestrian crashes where the pedestrian's crossing the street or the roadway, probably the pedestrian is coming from the driver's left. And I would argue that's no coincidence. That's because really where the lighting conditions from the headlamp system are the worst. I mentioned drivers being able to see pedestrians. The key factor is the degree of contrast between the pedestrian and the nighttime environment. And if a pedestrian is in dark clothing with the darker nighttime environment, there's not much contrast, and that makes it tough for drivers to detect the pedestrian. In fact, some Federal Highway Administration research showed that at night, the average driver of a vehicle using low beam headlamps will see a pedestrian in blue clothing about 55 feet in front of the vehicle. Well, think about that. At normal roadway speeds, 30, 35 miles per hour, the driver will have actually struck the pedestrian before they can even hit the brakes. So to avoid striking a pedestrian, the drivers would have to be traveling on the range of 20 to 25 miles per hour. And I don't know about your communities, but the communities I'm familiar with, most, even on residential streets, drivers are typically not going 20 miles per hour. They're going much faster than that. So this is a significant issue that I think we need to think about. And then one more thing I'll show with regard to this, maybe some of you have seen this. This shows older driver vision and how the nighttime vision changes with age in terms of the amount of light needed to see some feature in or on the roadway. Notice the amount doubles every 13 years. So college student age roughly would have, that's when our vision is the best. And then as we get older from that, notice our nighttime vision deteriorates. By age 33, average driver needs probably twice as much light. Age 72, a driver needs 16 times as much light, and an 85-year-old driver needs 32 times as much light to see the same thing as a 20-year-old. And so if you have a pedestrian on the roadway with dark clothing, that's not a good combination. To have a pedestrian on the roadway in dark clothing and then an older driver at night, to me, it's a kind of a recipe for trouble or some problems. The best way to, if I can back up here a minute. Yeah, I remember decades ago when I was in school, the advice was always wear white at night. But the truth is wearing white will only change this 55 feet to, I think, about 100 feet. The best thing for pedestrian safety at night would be for the pedestrian to have some form of retroreflectivity on them. Even if studies show, I think, even if it's as small as like a square inch of retroreflective material, if it's on the arm or the leg that's moving and can attract the driver's attention, that will advise the driver that there's something in the road ahead. And that retroreflectivity will change this number to about 500 feet, which should give the driver adequate warning, to steer away from the pedestrian or to brake for the pedestrian. Some other characteristics of pedestrians, and I may go through these pretty quickly. The average pedestrian walking speed, probably around 3 to 3.5 feet per second. Younger people, probably more like 4 feet per second. College students. But for example, the older couple you see in the image there, they're probably down around 3 feet per second. Special populations are even slower. For example, someone with a walker may be at around 2 feet per second. There's really no single design pedestrian. We need to accommodate a variety of pedestrians, and I'd like to look at 3 groups of interest. One is children, who tend to have the highest accident involvement rate with motor vehicles. The elderly, who have the highest fatality rate, meaning they're not hit as often as children, but when they are involved in a motor vehicle crash, they're more likely to be fatally injured. And then people with disabilities. So children, obviously, they're smaller in stature. They're not familiar generally, especially younger children, with the rules of the road, driver behavior. Often, also, they're very young because of their smaller size. They probably walk more slowly. They have 1/3 less peripheral vision, so they have more tunnel vision than, say, middle-aged or pedestrians or late teen pedestrians. And as I said, they may not be able to read or comprehend signs. Older adults also have a slower pace or gait, so they need more time to cross the street. Decreased agility and balance, so they need surfaces that are more predictable, smoother, and of proper cross slope. And they have reduced endurance, so they appreciate places to rest, benches and so forth. Amenities like that are very helpful to older pedestrians. Also, in steep areas, if you have steep sidewalks, handrails would be helpful. Recognize that they have poorer vision and slower reflexes. And then people with disabilities, generally, we talk about 3 categories of disabilities. One would be the mobility disability, meaning they may need an assistive device or maybe in a wheelchair. Sensory disabilities, the classic one would be eyesight or vision. You see the blind couple there. And then cognitive refers to impairments in information processing and decision making. People with mobility disabilities, generally lower speed, they need a high quality surface, have issues with endurance. And so we need to make sure we have wide facilities, have curb ramps at corners, pay attention to cross slope of the walking facility. People with vision disabilities get their information from sounds and textures and contrast. There's really 2 categories of vision disabilities. One is the blind pedestrian, who, as you see here on the upper right, they use a cane, and you can't see obviously in the static image, but she is swinging that cane in an arc in front of her, and she's looking for what they call shorelines. And this low wall here is a shoreline, so she can follow that. Another shoreline that's out of the image here would be, say, a curb. There's probably a curb between the sidewalk and the street. That curb is also a shoreline. Another group of visually impaired pedestrians experiences what's called low vision. They typically don't use a cane because they're not totally blind, but they cannot see detail. They can only see sort of general shapes and color contrast. So that's why we talk about the importance of color contrast and clearly defined pathways. And then I mentioned the cognitive disabilities. These include traumatic brain injuries, autism. One of the challenges here is because the breadth of different types of impairments and also kind of the severity of the impairments can vary greatly. But generally, as much as we can, and I realize especially in the East where we have an older infrastructure, it's hard to do some of these things, but if we can have kind of straightforward, direct environments with relatively simple street crossings and use easy to understand symbols, so follow, for example, the MUTCD, that will help make a more friendly environment for the cognitively disabled. Look a little bit at characteristics of bicyclists. Different folks over the years have categorized bicyclists in a number of different ways. This is one that seems to be fairly common. Notice they categorize the users into kind of 3 categories. The highly confident cyclist, which is a small percentage of the population, but they're comfortable riding in traffic. They'll use roads without bike lanes. They know the rules of the road in terms of bicyclists' rights and responsibilities. And then we have about the same size sort of group, 5 to 9% of the population, that we'd call somewhat confident. If they had their druthers, they'd rather ride on a separate shared use path, but they will ride in bike lanes or on a paved shoulder, but probably not in traffic. And then the biggest group, over 50% of the population, falls into what's called the interested but concerned category. They may not be comfortable with bike lanes. They may actually bike on the sidewalks. And they probably prefer a separated bicycle facility like a multi-use trail or maybe a quiet, traffic calmed residential street. We also need to consider the bike as a design vehicle in terms of sizing our facilities. And you can see there's quite a bit of variation in terms of types of bicycles, bicycles with trailers behind them, those sorts of things. So for your facility, you probably need to pick, which one of these would be your design vehicle. And then the bike dimensions, typically we assume a riding width of 4 feet. A shy distance, say to other cyclists, would be 2 feet. Lateral clearance to trees and posts, things along the biking facilities, 4 feet. And a typical required height of the operating space would be 100 inches, or what's that, 8 1/4 feet, I guess that works out to be, 8 feet 3 inches. Where you have higher motor vehicle volumes or truck and bus volumes or high speeds, a more comfortable operating space for bikes is probably 5 to 6 feet. And recognize that we're on a roadway that has on-street parking, probably 5 to 6 feet is desirable to provide space for the opening of car doors to avoid what's called the dooring problem, which is and can be a serious issue for bicyclists. Another big consideration with bicycles, and we'll talk more about this probably next week, is that due to the small tire contact between the tire and the road or riding surface, things that really are of no concern to a motor vehicle operator with 4 bigger tires on the pavement are a real issue for bicyclists. So things like longitudinal seams, like here, the gutter pan and the pavement, that if that's not flush, that can catch a tire and cause a loss of control. Or notice here in the center, loose materials on the travel way, especially in a curve like this. This is troublesome. Or steel plates. We'll talk a little bit about steel next week. Steel kind of in any form in the riding area for a cyclist is not good, especially if, say, this steel plate is wet. And then notice here the pavement has been milled out or removed in preparation for a paving project, and so we have some steel kind of jutting up above the pavement that can cause some serious issues. So that wraps up kind of the background and the discussion of pedestrians and bikes. We're glad to answer any questions or concerns anyone has. Mike, did any questions come in?
Hi, Ron. At the moment, we don't have any new questions, but we certainly encourage anyone who has a question to type that in to the questions box. And also, Ron, whenever you want, we have an additional poll question we could do.
Yeah, this is a good time. Thank you for reminding me. Yeah, this is a good time for the poll question.
Okay. So we have launched our 3rd poll question for the day, and we'll give everybody some time to respond.
And I realize all of these may be challenges for you, but I'm going to force you to pick what's your biggest challenge. I've been told this in other classes that maybe this should be multiple choice so people could pick more than one. But in this case, we're just asking for the biggest challenge.
And we have responses arriving already, so that's good. About 70% responded so far. Okay, a few more seconds. All right, very good. So we had 6% said topography, 13% said one or more major barriers, 30% said an old transportation system that's hard to retrofit, 39% finding sufficient financial resources, and 11% political will of local officials.
Okay, good. Very interesting response there. Yeah, probably not surprising that finding financial resources came out number 1, and then also since we're here kind of in the East Midwest area, the old the existing transportation system that's hard to retrofit is certainly an issue. So thank you for that.
Yep.
Well,
Ron, we do have one question.
sure.
Well, we have two questions now. And that's good. The first question, Michael is asking, what might be some situations where use of the no pedestrian crossing sign would be appropriate?
Good question. I'm trying to think here. And I wish I had a sketch or a photo I could show you all, but because I'm visualizing one. But imagine a four approach intersection, maybe in a suburban area. So there's maybe some development, but some quadrants maybe just grass or natural forest type vegetation. And maybe for safety reasons, primarily, I would hope, or maybe for ADA accessibility reasons, maybe instead of having 4 marked crosswalks, the agency has decided to say just have 1 marked east-west crosswalk and 1 marked north-south crosswalk, because maybe they feel if the other crosswalks were marked, there's some safety or accessibility issues there. So you may want to put that pedestrian prohibited sign to kind of prevent the pedestrians from crossing, or let them know you don't want them to cross at those unmarked crosswalks. But that's what I was talking about. You can't, in that case, you can't just put up the sign. You need to also put up either some type of like a railing or barricade at the end of that sidewalk at the street to prevent somebody from crossing there, so that a blind pedestrian could detect that, or else you'd have to design the end of your sidewalk so that the sidewalk doesn't go all the way to the curb, so that there'd be a few feet grass strip there, so that the blind pedestrian could detect that with their cane. They can detect the grass and realize the sidewalk doesn't continue, and that they would have to cross at the marked crosswalk. So there'd be 2 of those at the corners, I guess, where the 2 crosswalks they're legal crosswalks, but they're not marked crosswalks, where you don't want the pedestrians to cross. I hope that was clear. I wish we had a drawing or something I could show that.
Thanks, Ron. As a follow-up to your comments, Michael says, would a few plastic delineators be appropriate as that barrier?
If you're talking about kind of the flexible post type delineators, I would say no. It would need to be something that's continuous across the sidewalk that would be detectable with a cane, with the cane tip of a blind pedestrian.
Okay, thanks, Ron. We have a question and a comment from Anthony. The question is there more of a trend to get bikes out of the roadway via shared use paths, or shared paths, pardon me? And then his follow-up comment was, the shared path challenge is finding the best side of right-of-way to locate.
Yeah, that's a good question. I don't know if I'd say trend, but I think wherever possible, agencies, are trying to find like a side path, or where I am right now, I'll talk more about it later, but here in northern West Virginia, our topography is pretty rough compared to, say, central Ohio or northwest Ohio, but we're blessed with back in the day, this was a big coal mining region, and the coal mines are gone now, but what was left behind was a network of rail lines that have now been converted into rail trails, we call them, or a good, nice network of shared use paths. So we're kind of blessed if you can do that. You can really get your people even off or out of the roadway right away entirely onto some independent path. That would be the best thing. I realize that's not always possible, but yeah, otherwise probably try to get them onto some sort of side path or something like that. And we'll talk more about that on day 4.
Okay, Andrew is asking, what design speed should be used for bicycles?
Can we address that when we get to day 4? We'll talk about bike facilities. Good question. We'll get to that when we get to day 4.
Okay. We have another Michael who is asking, says crosswalk speeds are variable due to different users. Is it wise to design for the slowest crossing pedestrian or use an average of the range of crossing speeds?
Oh, that's a good question too. And that's sort of one of those gray areas, I guess. Yeah, I mean, I would say whoever asked the question, Michael, you recognize the different capabilities of the users, and that's a good thing. The reason I'm hesitating is I mentioned that some pedestrians, disabled pedestrians, maybe using a walker or something like that, may have walking speeds of 1.5 to 2 feet per second. So I'm not sure we'd want to design our, say, signal timing for that. I mean, I guess if you could, that would be good, but that's kind of a low walking speed. What I'm hoping is that in the future, and I think some communities are actually using it. I'm not sure how well it's working yet, but I'm thinking in the future technology will help us there. I think we'll have pedestrian detection systems that could detect a pedestrian is still in the crosswalk and then hold that signal for them until they can get across. In the meantime, if we don't have that technology, what I would probably say is maybe think toward the, I don't know, lower end of your or slower speeds and see what you can work with in terms of your other, traffic issues and so forth, and maybe use that lower speed, even though recognizing that that still may not accommodate the, like I mentioned, the person with the walker or that sort of thing. And that is still a challenge, I think, until we have maybe the technology that can help us address that.
Okay, next question from James. Is there guidance for when bike share symbols are added in the roadway, speed, volume, etc.?
Can I address that on day 4 as well?
Sure.
Good question. We'll talk about that on day 4.
It looks like there was a follow-up comment from Brad. Was your jurisdiction gifted this right-of-way? We are finding right-of-way from railroads that have been abandoned are far too expensive.
Yeah, I mean, it took a long time for them to make the legal, negotiations with the railroads to work it out. But and some of the sections they may have had to pay for, but yeah, otherwise, I think they were able to work out some sort of a deal, where it was donated or, for a few dollars or something like that. So yeah, we were blessed in that sense that generally, I don't think we had to pay a whole lot to get the land for the trails. So we were fortunate.
Okay, there's a comment and question from David. He says he has looked at Europe practice for speed and traffic counts for streets with bikes and sees US practice allowing bike lanes on highways with higher speeds and counts. Any comments?
Could you repeat that?
Okay, he says, I have looked at Europe practice for speed and traffic counts for streets with bikes and see US practice allowing bike lanes on highways with far higher speeds and counts. Any comments?
Yeah, I mean, and this is just a personal, more, not that I've been in Europe that much, but a little bit. It just seems that in Europe, I think speeds generally, motor vehicle speeds tend to be maybe lower. And just a personal observation, drivers maybe tend to be more thinking about the other users, the pedestrians and the bicyclists. So, I mean, I guess I'd agree with that observation that, yeah, I think in the US, we do find, sort of higher speeds, higher volumes on some of those where we have bicycle facilities.
Okay. Well, thanks everybody for your questions. And that was quite a few, Ron. So that's good.
Yeah, very good questions. Keep them coming. Well, now let's go into some design issues which were mentioned in some of the questions. And I'd like to talk about a little bit about flexibility, design controls, and design elements. And I want to urge that we think about design flexibility, because we can use existing tools in creative and varied ways to solve some of the design challenges. But we do need to understand the variables and the thresholds and the alternatives to achieve these objectives. But here are just some of the existing standards and guidelines that I think give us some flexibility. And some might differ with me, but the MUTCD, for example, for certain things, there's not much flexibility, but for other things, it encourages us to use and requires us to use engineering judgment, traffic engineering judgment. Same thing with AASHTO's policy on geometric design of highways and streets, the Green Book, and supplemental guides. They really do give us flexibility. For example, I think for lane width, as I recall, the Green Book says lane widths can be between 9 and 12 feet. And so that does give us some flexibility. Same way with the Highway Capacity Manual, the NACTO guides that are out there, and also in terms of ADA, the Public Rights of Way Accessibility Guidelines, PROAG. Obviously, they're strict in terms of things like cross slope and grade and so forth, but in terms of how we sort of apply that in given situations in a given context, I think there is plenty of room for kind of flexibility to kind of solve some of these problems and make an accessible right-of-way that still complies with the PROAG guidelines. So I like to encourage folks, rather than to think of these as sort of problems or barriers to us, think about how we can think outside the box a little and have opportunities to use kind of our knowledge and our education and experience. One issue with roadways, of course, and the question came up too with respect to bikeways as well, or bike facilities, which we'll talk about next week, is design speed. And this influences, as the slide says, other design criteria like horizontal and vertical alignment, lane width, and so forth. And the Green Book does allow for flexibility here. It gives us a range of values. Other more recent maybe resources like NACTO and ITE do recommend lower design speeds where you have pedestrians and bikes. And so we really need to consider the context. Is it urban, suburban, rural, and the speed of the road? Another issue is design vehicle. And notice the design vehicle should be the frequent user of the street and should dictate lane widths and corner radii. Then consider the use of a control vehicle or infrequent user of the intersection to understand how larger vehicles will negotiate the intersection. And we can do things like recess stop bars away from the intersection to allow that control vehicle encroachment. And we maybe assume that emergency vehicles will use the entire right-of-way. So here's an example. It looks like maybe a transit bus here, and this drawing would be the design vehicle. And so notice we're the swept path of that design vehicle. Sorry about that. The control vehicle will probably have to go out of its lane to make that turn, but it would be an infrequent user of the roadway or the intersection. Curb radii and curb extensions. I would design the curb radii for the vehicle that turns at the intersection most frequently. As the slide says, there's smaller curb radii and curb extensions position vulnerable users in a more visible location. They reduce crossing distances, reduce motor vehicle speeds, and give additional space for curb ramps. So curb extensions from that have benefits that you see there. Probably for local urban streets, use a curb radii between 10 and 15 feet. Related to turns, another issue is the channelized right turns. These are not very pedestrian friendly, especially, well, for all pedestrians, but especially for the visually impaired pedestrian. But they can, as it says here, break up a longer crossing distance so the pedestrian can do it in stages. And if you design these things properly with some compound curves that slow the vehicle paths, you can prioritize pedestrian movements a little more. And I would point out in these islands here, in this pork chop island, these need to be raised islands that are detectable by the visually impaired, curved islands, not merely painted islands. Here's the concept of effective curb radii, where you have on-street parking or bike lanes. Notice we're using kind of the effective radii rather than the actual radius to create a more compact intersection that tends to encourage lower vehicle speeds. Design vehicle encroachment, where you have large vehicles that make occasional turns. Think about mountable truck aprons so they don't encroach into the pedestrian waiting areas. And it's important to keep these visually distinct from both the travel lane and the sidewalk. And here we see a couple examples. Notice the one on the left here. I would say that the thing I don't like about this is that notice it doesn't appear to be visually distinct versus the one here on the right that is visually distinct by its color and maybe its texture as well. Sight distance, a critical element in design from a safety standpoint. There are many types of sight distance. We don't have time to go into them in this session, but one of the key ones is stopping sight distance, of course. The distance a driver can see ahead in order to observe and successfully react to a hazard, an obstruction, a pedestrian decision point, or whatever it might be. And really, this is a fundamental requirement of roadway design. Every roadway should, along its length, have adequate stopping sight distance. The Green Book provides some criteria for what's known as intersection sight distance, for design of sight distance at intersections. It's also important to make sure we have good sight distance in advance of pedestrian crossings so that bicyclists and motorists can see pedestrians. So that on some streets, for example, that may mean removing a parking space or two to provide adequate sight distance. Horizontal and vertical alignment, this would be our curves and hill crests and sags and curves to the right and left. And it affects speed, and curvature is affected by speed. So we want to have an alignment that kind of balances safety with a reasonable operating speed. And probably the best source here would be the AASHTO Green Book. Another issue for pedestrians and bikes is access management, or sort of driveways and ingress and egress to land uses along a roadway. As you see here, every driveway is a potential conflict point for pedestrians, also for bicyclists as well. We don't see any bikes in the image, but for bicyclists on that street, these driveways are potential conflict points as well. So here we see on the left, kind of an uncontrolled access, and almost the entire frontage is available for motor vehicle use. I mean, notice there's also some tripping hazards here at the sidewalk. This is not the way to do it. But what I did want to note here is this location this driveway has actually been related to a couple serious injury pedestrian crashes that have occurred on this roadway. Over here outside of the image are some pedestrian generators, and so pedestrians tend to cross mid-block, and then you have drivers making left turns into and out of here, and just a lot of conflicts between not only motor vehicles but between pedestrians and motor vehicles. So like I say, access management is important not only for motor vehicle safety but also for pedestrian safety. And then it's also an accessibility concern. Notice the sidewalk along this arterial has numerous driveways, and at each driveway, notice the cross slope of the driveway becomes or the grade of the driveway becomes the cross slope of the sidewalk. And these look like they exceed the 2% allowed by ADA. And then also you have the grade break issue here, which can present an issue for the mobility impaired. So obviously access management is a regulatory tool or policy tool, and we want to try to reduce the frequency of turning movements and conflicts caused by driveways. Typical strategies, consolidate driveways, maybe put in continuous medians or directional islands, or in some cases, even driveway closures. And here's an example, reducing what had been kind of 3 separate parking areas, each with their own driveway, working with the property owners to have kind of combined parking with 2 access points. And I think, Mike, we're about at the appointed ending time, aren't we? This is probably a good point to stop for the day. So I'll thank everybody for participating, for your good questions, and we'll see you at the same time tomorrow. So Mike, I'll turn it back to you.
All right, thanks, Ron, and we look forward to part 2 of this series tomorrow afternoon. So thanks everybody for attending.